Good morning or afternoon or whatever it may be. Here is your title for your table of contents. Today we're adding and subtracting fractions. It should only take one page. If it takes another page, we'll come back and we'll fix it. Don't forget you can pause or fast forward or rewind anytime that you need to. Alright, here's your title, adding and subtracting fractions. Let's get started. So let's think about the denominator in the video that you should have watched before of the different size pieces. The denominator determines the size of the pieces and how many parts it takes to make a whole, and the numerator tells you how many pieces you have. So we have these two items up here, and I'm going to shade in. I'll shade in two of these on this one, and you can draw this if you can. Remember, pause it if you need to. And I'm going to shade, let's see here, these right here. Okay, so the shaded part is what we have left. Alright, so let's look at that first one. The denominator tells us how many parts it has to make a whole. There are 1, 2, 3 total parts, and we have 2 of them remaining. We're going to add that to this one. How many parts is in there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 parts, and we have 1, 2, 3, 4, 5 of them remaining. So we can't combine these two things yet because they have different sized parts. Technically, what we could do is take, if this one is made up of 3 parts, that's made up of 9 parts. We could take and cut, I suppose, the 2/3 pieces into where they would be ninths, where it would be 9 total parts. So I'm going to use a different color here just to show the cutting so they fit. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we would be a ninth. So this new denominator, whoa, I got to take that little shape thing off. This new denominator would be a 9. Okay, and how many parts of that do we have? Well, there's 2 ways to do that. We can count them. 1, 2, 3, 4, 5, 6. Or, so we don't have to use models all the time. The question is, we change the denominator by cutting it, and we got from 3 to 9 by multiplying by 3. Just like other things that we've talked about in math, if you're going to do something to one, you have to do something to another. So you also have to do it to the top, or the numerator, multiply it by 3. So our new problem is 6 ninths. I know I'm getting a little close together, so I'm going to rewrite it. Okay, 6 ninths plus 5 ninths. Okay, so now we have nice equal parts. So when we put it together, it all looks the same. Okay, so we would still the total amount of parts is just 9. It takes a total, you have to have 9 of them to have a whole thing. Okay, and then we just add the numerators straight across, and we have 11. So that means we actually have more than one whole, right? We actually have one whole, which would be 9, and then how many do we have left over out of those? We have 2 left over, so it would be 1 and 2 ninths. If you don't know how to do that, it's really just like Norman and the donkey. 11 divided by 9, that's 1 time. Subtract, you have 2 leftovers, remainder of 2. So 1 whole, 2 out of 9. Okay, so your remainder is your numerator. Alright, so let's do, I'm going to write, I guess, one thing down here. Alright, so I wrote a few things down there. I'll go ahead and pause it and get that written. You must have a common denominator. We can't do any adding or subtracting without a common denominator. And And then whenever we add or subtract, we leave those denominators alone once they're the same. And so we just add or subtract the denominators. We add or subtract the numerators, the number on the top. Alright, so pause it if you haven't already. Alright, so number one. We have a denominator that is already the same, so that's great. That helps us out a lot. So the denominator in our answer is going to be 11. And now we just have to subtract 9 minus 4. It's 5 over 11. Easy, easy, easy right there. Okay? Alright, number two. We are adding, but our denominators are not, are not the same. So we have to think, how can we get them the same? Let's see here. We can't simplify them to where they're a 2 because we can't do that to the numerators. It doesn't work for the numerators. So instead, let's think about 8. Okay, if we skip count by 8. And then as we're counting by 8, so let's think about, does something match? Will 6 go into that number that we say out loud evenly? So let's go 8, then 16. 6 doesn't go into 16 evenly. 8, 16, then 24. So let's think about 6 going into 24. Well, it does. 6 goes into 24, what, 4 times? So that means our new denominator, we are going to change them both to 24. Okay, so we skip counted by 8 and we did it 3 times for the 8. Okay, 3 times for the 8. So that means it is now going to be 24. And whatever you do to the denominator, you also have to do to the numerator. So you would have to multiply it by 3 as well. You have to be fair. And so that is now 21. And then the 6, we want it to be 24 because they have that in common. But what do you multiply the 6 by to get there? You multiply it by 4. So you have to do the exact same thing to the numerator. Got to be fair. 5 times 4 is 20. Okay, so then when we add these up, which I'm out of space, so I'm going to do it down below, the denominator is going to be 24. Denominator doesn't change. And then 20 plus 21 is 41. So that's 41/24. That's an improper fraction, meaning the top is heavier than the bottom. We don't want that. So we need to turn that into a mixed number, meaning it's got how many wholes does it have, and then what's the remainder. Okay, so we're going to do 41 divided by 24. Remember, don't put the donkey in your house. It's gross. 41 goes into 24. It does not go into 4, but it does go into 41 one time. And we just subtract. I'm going to zoom in because I can't hardly write anymore. I'm going to borrow. This is now a 3. 11 minus 4 is 7, and 3 minus 2 is 1. So we have a remainder of 17. The remainder is the pieces left over. Okay, so 41/24 is the same thing as 1 whole. There's our 1 whole with 17 parts right there left out of 24 parts. 24. So when you add, which this is crazy, right? Doesn't look anything like it started. When you add 5/6 plus 7/8, you get 1 and 17/24. It's a lot of steps, but you just got to do one step at a time. There's no reason to think about all the steps at the very beginning. Just one step at a time. Okay. Then number 3, you are going to have negatives in your in fractions as well. It is possible. So, but don't worry about that negative right now. Let's think about our denominator first. Okay. If we skip count by 3, we get 3, 6, 9, 12, 15, 18, 21. And then if we skip count by 7, we go 7, 14, 21, 28. Well, what did you notice that matched in there? 21. So that means our denominator is going to be 21 for both of them. 21. And so how do we get from 3 to 21? Multiplied by 7. So whatever you do to the denominator, sorry, that sounded weird, you do to the numerator. Multiply it by 7. And then for the negative 2/7, how did we get from 7 to 21? Multiplied by 3. Be fair. Do the same thing to the numerator. Multiply that by 3, and that is 6. So, in my class, we talk about when we're adding integers, what do you have more of? Well, first let's make our denominator. Our denominator is 21. So let's look at this is all we're looking at now. Negative 6 plus 7. That's all we're looking at, okay? So what do we have more of? Do you have more negatives or more positives? You could use that little cancellation thing if you want. 1, 2, 3, 4, 5, 6 negatives. And 1, 2, 3, 4, 5, 6, 7 positives. This right here is called a zero pair because a negative 6 and a positive 6 equals 0. And so what's left? 1 positive. So that is 1 over 21 is that final answer. Alright, the last one. I have 3 minutes left on my video, so I gotta get going a little quicker. So let's go ahead and look at the denominator first, and then we'll talk about some rules. Obviously, they're not the same. So let's skip count. 4, 8, 12. Oh. Let's skip count by 3s. 3, 6, 9, 12. So that means our denominator is going to be 12. It's going to be 12. Alright, so how do we get from 4 down to the 12? We multiplied by 3. And how did we get from 3 to 12? We multiplied by 4. So do the same thing. Be fair. Be fair to the numerators. So this one here is now going to be 9. And this one here, 2 times 4, is going to be 8. And that is a negative. Okay? So we're subtracting here, and at North Belton we add the opposite instead. So we do not mess with that first fraction. We learned in my class why adding the opposite works, because subtracting a positive is the exact same thing as adding a negative. So instead of subtraction, we are going to add the opposite of 9/12. What's the opposite of 9/12? The opposite of positive 9/12 is a negative 9/12. And so now we just have a negative plus a negative. Okay? Remember, our denominator is going to stay at a 12. And now we're just getting more and more and more negative. We have 8 negatives here and 9 negatives there. So we're just getting more and more. So a negative 8 plus a negative 9, the answer is going to be negative because we're just getting more and more of them. And negative 8 plus negative 9 is negative 17. So that is improper. We have to turn that into a mixed number, which the answer is going to be negative. That doesn't change. So our denominator of our fraction is still going to be 12. So how many times does 12 go into 17? One whole time. One whole time. And subtract with a remainder of 5. So it is negative 1 and 5/12. Okay. Next video will be some assignment help. I know there's a lot of steps on this and you're thinking it's difficult, because it is, and that's okay. Just do the best you can.